multiplying and dividing rational expressions. In this video, we'll multiply rational expressions and divide rational expressions, and we'll always remember to factor. Let's multiply these rational expressions, but we must. Let's just work our way through one at a time. 3x minus 6 has a greatest common factor of 3, and when we factor out 3, we get x minus 2. X squared minus 2x minus 3 factors into two binomials. They both begin with x. For negative 3, the only factors are 3 and 1, and since the negative 2 in the middle is negative, the 3 must be negative. So now I have factored the first rational expression. Now let's look at x squared minus 4x plus 3. That again factors to two binomials. They both begin with x. I look at 3, the only factors are 3 and 1. It's a positive 3, but I have a negative 4 in the middle. So negative times negative gives me positive, and negative plus negative gives me the negative 4 in the middle. And finally, x minus 2 is already factored, but I'll just put it in parentheses so it looks like the rest of the binomials. Now that I've factored, I get to do the fun part, which is canceling. So anything that's on the top can cancel with an identical thing on the bottom. So here's x minus 2 and x minus 2. They can cancel. And I have an x minus 3 on the top to cancel with the x minus 3 on the bottom. But x minus 1 and x plus 1 are two different binomials, and 3 doesn't have anything to go with it. So when I simplify, I have the 3 and the x minus 1 on the top, and I have the x plus 1 on the bottom. So when we simplify the multiplication, it's equal to 3 times x minus 1 over x plus 1. I want to multiply these rational expressions. But first, well, let's start by factoring 3x squared minus 14x plus 8. Since the leading coefficient is not 1, I need to use the AC method or the trial and error method. 3 times 8 is 24. I'm going to use the AC method, and I need factors of positive 24 that add to give me negative 14. So when I start listing factors, right away I find 2 and 12, and I can use those to split the middle term. Now that I've written negative 14x as negative 2x minus 12x, I can split the four terms and factor by grouping. So in the first half, I factor out an x and I get 3x minus 2. And in the second half, I factor out negative 4 and I get 3x minus 2. So the factors are x minus 4 and 3x minus 2. X plus 5 can't be factored further. 2x minus 21 can't be factored further. 21 is not even. But 3x minus 12 I can factor out a 3, and that's going to give me x minus 4. Well, now comes the fun part, canceling. I see an x minus 4 on the top that I can cancel with an x minus 4 on the bottom. But that's it for canceling, so I'm left with 3x minus 2 and 2x minus 21 on the top, and x plus 5 and 3 on the bottom. And there we go. Now we're going to divide rational expressions. It's not much different from multiplying, so you know what I'm going to say. 3x minus 3 I can factor out of 3, and I get x minus 1. X squared minus 2x minus 3 factors to x minus 3, x plus 1. This x minus 1 here can't be factored further, but x squared minus x minus 6 can. Each factor begins with x, and 6 is 3 times 2. 1 is negative and 1 is positive, and I know 3 is the negative one because I want to get negative 1 when I add them together. Well, there we go, and now remember the phrase invert and multiply? So to divide, we change the divide to a times, and we flip the fraction that's after the division upside down. The first fraction stays the same. And now comes the fun part. We can cancel. So I have an x minus 1 that cancels with an x minus 1, an x minus 3 that cancels with an x minus 3. And I'm left with 3 and x plus 2 on top, and just x plus 1 on the bottom. And there we go. We're going to divide these rational expressions as soon as we... Well, first I want to factor 10x squared plus 9x plus 2. I'm going to use the AC method, so I'm going to multiply 10 and 2, that's 20, and I'm going to find factors of 20 that add to give me 9, which are 4 and 5. So I split the middle term with 4x plus 5x, and now I can factor by grouping. I factor 2x out of the first half, and that gives me 5x plus 2. And out of the second half, I just have 5x plus 2, so I factor out a 1. And that gives me 2x plus 1 times 5x plus 2. 3x minus 3, I can factor out a 3, and I get x minus 1. Now I'm going to look at 2x squared minus 5x minus 3. So 2x squared minus 5x minus 3 has to factor, 2 and 3 are both prime, so it has to factor into 2x times x. Now, one is going to have a positive and one is going to have a negative, and I'm just going to try things until I get negative 5 in the center. So I'm going to try putting the 3 here because a negative 3 times a 2 will give me a negative 6. And then if I write 2x plus 1, I'm going to add a positive 1. That'll give me the negative 5. So that factors to 2x plus 1 times x minus 3. And on the bottom I've got an x minus 1 that can't be factored further. Since it's a division problem, the first fraction stays the same, but the divide changes to a multiply, and the second fraction flips upside down, and the numerator and denominator switch places. And there we go. Time for the fun part. So what can I cancel? Well, 2x plus 1 cancels with 2x plus 1. X minus 1 cancels with x minus 1. Anything else? I don't see anything. So I'm left with 5x plus 2 on the top and 3 and x minus 3 on the bottom. And there we go.